Hi guys, welcome back. Myself Akshayan. I'm currently pursuing my BE in SVC in Bangalore. My topic is quicksort. Today I'm going to discuss about sorting and its types. What is quicksort? Implementation of quicksort, algorithm of quicksort, an example of quicksort, time complexity of quicksort algorithm. At last, some pros and cons. Sorting. Sorting refers to the process of arranging elements or data in a specific sequence. It is a fundamental operation in the world of computer science and data processing. Sorting is imperative in diverse applications for the purpose of organizing, searching, and scrutinizing the data proficiently. Some types of sorting are bubble sort, selection sort, merge sort, quick sort, heap sort, radix sort, and counting sort. Quicksort. The quicksort algorithm is a popular sorting algorithm that is widely used due to its high efficiency and speed. It works by selecting the pivot element from the array, partitioning the remaining elements into two subarrays, and then recursively sorting each subarray. One of the key advantages of quicksort algorithm is its ability to handle large datasets with ease. It has an average time complexity of n log n, making it one of the fastest sorting algorithm available. Additionally, it is relatively easy to implement and can be adapted to work with different types of data. Moving on to its implementation. To implement quicksort, we first need to understand the basic steps involved in the algorithm. The first step is to select the pivot element, which is used to divide the array into two smaller subarrays. The next step is to recursively apply the same process to each of the subarrays until the entire array is sorted. This function selects a pivot element and rearranges the array so that all elements less than pivot come before it and all elements greater than the pivot come after it. We can recursively call the partition function on the left and right subarrays until entire array is sorted. Algorithm for quicksort. This is the algorithm of quicksort. The code is a function that takes an array and returns the position of first element in it. The code starts by declaring a variable called p, which will be used to store the position of first element in A. Then it declares two variables I and j, which are used to keep track of where we are in a looping process. The next line is what makes this code work. Repeat, that is repeat I less than minus I plus 1 until elements in A is greater than or equal to p. This means that as long as there is an element less than or equal to p, we continue with our looping process. This continues until either I reaches j or there is no more elements left in A. In other words, when all the elements have been compared against p. In this case, if I ever reaches j, then swap their values so that they can compare them again later on down the road. The code attempts to partition of array of integers into two subarrays. The first step in the code is to find the position of smallest element, which will be p. Next, it swaps all the elements in positions I less than or equal to p with those positions j less than or equal to p until it finds a smaller element than p. Finally, it returns the position of that smaller element. In this example, I have taken an array of 10 elements which is unsorted. You can either choose 3 or 4 as pivot element. I have taken 4 as pivot element. The main aim of the first part of algorithm is to bring the pivot element in middle so that we can equally divide the array into left and right subarrays. Now element 4 is in middle of the array. Elements smaller than 4 is considered as left subarray and elements larger than 4 are considered as right subarray. Left subarray and right subarray are sorted recursively. This is the sorted array of 10 elements. Moving on to its time complexity. Moving on to Quicksort's best case efficiency, average case efficiency, and worst case efficiency. Quicksort's best case time complexity is n log n. Quicksort's best case occurs when the partitions are as evenly balanced as possible. In other words, their sizes either are equal or are within one of each other. Moving on to average case. Quicksort's average case time complexity is also n log n. Average case complexity occurs when the array elements are in jumbled order, that is not properly ascending or not properly descending. Quicksort's worst case complexity is n square. The worst case occurs when the given input array is sorted reversely and we choose the rightmost element as the pivot element. Here are some advantages and disadvantages of Quicksort. Advantages: it is highly efficient, it is flexible in large data sets, good for parallelization, it is easy to implement and understand. Moving on to its disadvantages: not suitable for small data sets, it is not stable, performance can greatly suffer in worst case scenario, it requires extra memory space. Conclusion. In conclusion, sorting algorithms play a crucial role in computer science and everyday life. They allow us to efficiently organize data and make sense of it. We have discussed the different types of sorting algorithms, how they work, and specifically explored the quicksort algorithm. By understanding these concepts, we will be better equipped to tackle real-world problems that require sorting. I encourage you to try implementing Quicksort on your own. It may seem daunting at first, but with practice, you'll gain deeper understanding of how it works and why it's so powerful. This is all about Quicksort algorithm and its implementation. Hope you like the video. Thank you.